today we will continue to talk about object-oriented programming. Okay, so today we will focus on the further OOP concepts in Java. And the first concept is called encapsulation. So encapsulation in Java is the process of wrapping up variables, data, as well as the methods, code that acts on the data together as a single unit within a class. So for example, suppose you have two classes. One is called car and another is called dog. So the dog class and the car class are two entirely distinct entities that are not related to each other. So their data, instance variables, and their methods which act on that data are encapsulated within their respective classes. This means that all data and methods related to a car will be in the car class. All data and methods related to a dog will be in the dog class. And you can create as many objects of these classes as you want. So the methods and data in the dog class will not be related to the data and methods in the car class. So this is an example of a class called car. So you can see that it has its own instance variables, which are string type variables called make and model, and it also has a void type method called drive. So you can put your actions to drive the car inside the method. And here is an example of a Java class called box. So you can see that the box class has its variables like height, width, and depth, and their values are 10. And also it has its methods called get height, get width, set width, and get depth, and set depth. So these are the methods to access or modify the data inside the box class, which we will talk about later. So these are the codes to create a new box type object which belongs to the box class. So we can review this, which we talked about last time. So you can see that we define a new box type object called B1, and we give it 3 initial parameters, which are 5, 5, and 5 here. So which means that now we have a new object called B1, which it has a height which is 5 and a width equals to 5 and depth, which is also 5. So the next concept is called inheritance. So inheritance is when one object acquires many of the properties and behaviors of a parent object. So inheritance provides code reversibility, allowing us to minimize redundant code by organizing shared attributes in parent classes known as superclasses. The OOP languages allow a class to add a superclass when it's declared. Child classes, aka subclasses, inherit all public and protected variables and methods from its superclasses, which means that if you have a child class, you can use all the methods and variables declared in this parent class, and you don't have to declare it once more unless you want to override it to add some new functions to it. So using a visual example, red apple and green apple only need to define what makes them unique from each other. Their shared attributes will reside within the parent class, which is the class apple. This is because red apple and green apple all belong to apples, right? So these attributes shared between apple and orange will reside within the fruit class. That is because apple and orange all belong to fruits. So this is the concept of inheritance. So we have an example here. You can see that vegetables and fruits are all in a type of food. So they are defined as subclasses of the food class. And you can see that lettuce is a subclass of vegetable, and apple and orange are subclasses of fruit. And so for apples, it is also the parent class of red apple and green apple. So if you want a new method which has some kind of new or upgraded functions, you can override an inherited method. So a class can override an inherited method, replacing it with its own version. So to override a method, the new method must have the same return type, same name, and same numbers of parameters. So when do you need to override an inherited method? It's like, for example, for the fruit class. For example, suppose you have a method called getName to return the name of the fruit. But however, for the red apple class, for example, it is a subclass of apple, and apple is a subclass of fruits. So the red apple can inherit the getName class from the fruit class. So you can also use the getName class for method for the red apple class. But however, if you want to return the name of the red apple, you probably want to add a string apple subsequent to its name. For example, you want to return the name of the apple called A apple or B apple. So you can override the getName method in the red apple class to add a string which has the value apple to the name of the apple when you return it. So it has the same. It should be a void type function, so it has no parameters, but it has the same return type with the getName method from the fruit class. So their return types are all string. And when you call the method new method from the red apple class, you can get a name with an apple with it. Okay. So the next concept is called polymorphism in Java. So polymorphism is the ability of an object to take on many forms, thereby allowing a method to perform different actions based on which the object method is called upon. So for example, in the depiction below, we use the steering wheel in the center as an analogy for polymorphism in Java. No matter what car you're driving, there is a steering wheel. The steering wheel remains constant. However, depending on what type of car you're driving, a sport car vs a vintage car vs a semi-truck, the mechanism behind the wheel and the behavior it used can be quite different. So using the polymorphism OOP concept in Java, we can replicate a concept to make our code easier, more flexible, and more creative. So you can see from the picture that all kinds of cars all have this. So it can represent the concept of polymorphism. So now we'll talk more about the code techniques when doing with OOP. So for the field defined in a class that we talked about last time, if we want to limit its access from outside, we can add a keyword called private to it. So we can turn it into private fields. And private fields can only cannot be get called from outside of the class. So if you want to get its value or operate with it, you can also do this inside the class. For example, we have an example here of we have a public class called rectangle, and its fields are all private fields, x, y, width, and height. So if you want to access the value of the field here, we can only add code inside the rectangle class to access it. And if we, for example, we define a new object which is rectangle type from outside the class, we cannot directly use, for example, suppose the name of the object is called R1, we cannot directly use R1.x, for example, to get the x value of the object. So what should we do? We should add some accessor or modified method for the field. So we can see from the code here. So this is a class called rectangle, and here are its fields, which are x, y, width, and height. And here is the access method. So for example, if we want to get the x value of the rectangle, we can define a class called getX, and this method must be a public type method so that it can be called from outside of the class. And then inside the getX method, we can use return this.x.
So it would be the same for the method getY. So by writing return this.y, you will get the y value of this class. And the next we are going to talk about is get width and get height. So these are also very similar to this getX and getY. So by writing return this dot width, this dot height, we will also get the value of these private variables, or you can say these fields. And so these are how you will get the value of the field inside the class. And next we'll talk about how you can rewrite or how you can make some modifications to the values of these fields. So you can look at this method called set new x. So inside this method, you first have a parameter called new x. So this is the new value of the x that you want to give to the x, and then you will have the this dot x equals to new x inside the pair of curly braces. So this dot x refers to the field inside the class, which is x, and by assigning the value of new x to it, you can complete the process, the operation of assigning the new value. And next, you will see another example of setting values. So you can see the example set location. So inside this method, we have two parameters that we pass in. They are new x and new y. So the first thing we do is to add an if statement. So if the new x is smaller than 0 or the new y value is smaller than 0, we'll do the process of throwing a new illegal argument exception. So I'll explain this line of code. So inside this method, we want the value of x or y to be greater than 0 because they are the locations of the rectangle, and therefore if they are less than 0, they are just wrong or illegal information. So we want Java to identify that and tell the users when these values are passed in. So when we write this line of code, throw new illegal argument exception, so this time the Java will sense the values and it will just end the process and go back and tell the user that the information you have is not legal. And then we'll just continue the process of assigning the value of new x and new y to the x and y field inside the class if these passed in values are greater than or equal to 0.